Hello friends, welcome back to your channel. In this channel, we try to solve the previous year's physics question papers of NEET undergraduate exam, which is held in India. This is also helpful for those who are preparing for JEE mains because they are NCERT related. We have made all attempts to solve this in a very student-friendly manner so that you can easily understand the concepts and you'll be able to apply them going forward. We have tried our best to solve the different types of questions which appeared in the earlier NEET question papers so that you do not miss them. We take a lot of effort in reviewing the previous year's question papers and sharing with you only the best ones so that they make your preparation more complete. If you like this content, we urge you to like the videos. This motivates us to create more educational content for you and help you in your preparation for the exams. We also urge you to subscribe to the channel so that you are immediately informed of any additional content available in the channel. We hope you are able to follow the solutions easily. If you still have any questions or doubts, then please feel free to add in the comment section and we will revert to you at the earliest possible. So without much ado, let's get started now. So in the previous video, we had actually solved the first 5 questions given in this one. So you can go and refer to the previous video. So we have solved till here. In this video, we'll solve from question 6 to question 10. And in the further video, we'll solve the rest of the problems. Okay. So let's look at this particular question here. So it's given that there's a block here. There's a block here at the top of the incline, right? So the block at the top here, obviously it will have a tendency to fall, right? It will have a tendency to fall, and because of some friction which is acting in the opposite direction, it will not be allowed to fall. Correct? It will not be allowed to fall. In the previous question, I'll just take you to the previous question here. We had told you that if you look at this question, we had told you that if you notice this, we had told you that the friction, the acceleration, if there is no friction, it is A is equal to G sine theta. Okay, and if there is friction, the acceleration is given to be A is equal to G sine theta minus mu G cos theta. Now these are the, we'll be applying this, and that is why I'm taking you through them. Okay, so it is given that a body, when it falls on an inclined plane of angle 45 degrees, so this is given to be 45 degrees. This is given to be 45 degrees. Okay, so let me change the color of the pen. Yeah, so this is given to be 45 degrees here. Okay, it's going to be 45 degrees here. As I told you earlier, when it is falling along the plane without any friction, the acceleration A is given equal to G sine theta, right? G sine theta. How is that coming? So this is the direction of G here, correct? The direction G vertical. It falls vertically, it falls in acceleration of G. Now, since this is theta, if this is theta, then this is 90 minus theta. So this becomes G sine theta. Okay, and you know that this is G cos theta. Okay, so acceleration in case of no friction, if there is no friction, then the acceleration at which it falls is G sine theta. Okay, and in case there is friction, if there is friction, then the acceleration is equal to G sine theta minus mu G cos theta. Okay, right? So we know these formulas, right? I just gave you the basic understanding of these formulas first. Okay, so it's given that when this body is falling from top, it takes half the time to fall without, if there is no friction on the surface. It means if it takes if it is taking on a frictional surface, if there is friction, if it is taking a time t1, means if there is friction, it is taking a time t1, time taken equal to t1. Then if there is no friction, then time taken to fall from the top is equal to t2, and is given by that t2 is equal to t1 by 2. Is given that it takes half the time here. If you notice this, right, if you notice the question, if you notice given that it takes half the time to slide down the incline on a friction surface, a frictionless surface, right? So now what is the formula we know of, right? So S is equal to ut plus half into a t square. Okay, this is what we know. If there is no initial velocity while falling down, means if it is falling from the top here, right? When it's falling from the top here, okay, at that time it is a rest, right? It is falling from here, it means u is equal to 0. Okay, so in that case the S is equal to 0 plus half a t square. Okay, means t square is equal to 2s by a. Okay, see why we are taking this formula, because in this case we don't have any other thing, right? We just know the time here, we know that the length is the same in both cases, and we know obviously the what is the acceleration in each of these cases, right? In friction and without friction, what are the acceleration, right? So we need to find the coefficient in this case. Okay, so t square is equal to 2s by a. Now if we compare both the times, then what happens here? So in both the cases, if it is friction or without friction, so I can say here that t square is proportional to 1 by a, because s is the constant, the length of this particular incline is constant in both cases, whether it comes without friction or with friction. This is a common length. Okay, so it means t square is proportional to 1 by a, right? So I can say that if t square, when there is no friction, right, no friction, divided by t square when there is a friction, is equal to t square no friction. So it means what is the acceleration? No friction, that will come this side, right? No friction, the acceleration g sine theta, right? G sine theta. And what is the, in the case of friction, it is this one, right? With g, I can say that g sine theta minus mu cos theta, right? So this is what we know, right? So GG we cut here. Also, the angle or the theta as it is given here, it is 45 degrees, right? So when theta is 45 degrees, I think all of you know that when theta is 45 degrees, sine theta is equal to cos theta. Okay, all of us know that, right? It means then in that case, I can write here is equal to g. I can write here g sine theta. Okay, sorry for that. Okay. So if this is sine theta is equal to cos theta is equal to k, if both are the same, I can write here k minus mu k upon k, right, is equal to k 1 minus mu upon k. Well, k gets cancelled. This is equal to 1 minus mu. Okay, now let's look at the T and F. There's no friction, divided by TF, right? If there is no friction, it is given that it is half the time with the friction. Okay, right? So now what is T no friction? So T no without friction and with T with friction, this is actually equal to 1 by 2, right? We saw this here also, right? We saw this here. Okay, so if T friction is 2, then T non friction is 1, is half of that, right? So it means T non-friction divided by T friction whole square is equal to 1 by 4, right? Now let's go back to this thing, right? So we said that TNF upon TF square is equal to 1 minus mu, right? It means 1 by 4 is equal to 1 minus mu, okay? It means mu is equal to 1 minus 1 by 4 is equal to 3 by 4, okay? Okay, so it means mu is equal to 3 by 4, okay? So this is the answer. Okay, so if you look at the answer which are provided to us, then this should be the answer, right? Okay, let's go to the next question now. Now let's look at this problem, question number 7. So in this case, what is given here is that there is a block which is resting against this particular card, okay? It is resting against this card and this cart is moving forward, okay? So this cart is actually moving forward here with a definite acceleration, okay? Imagine that the acceleration is equal to A, okay? The acceleration is moving forward here. The wheels are rolling like this, okay? The wheels are rolling like this, okay? And this is moving forward. Okay. So now when it is moving forward, then anything which is resting against this particular surface, right? If anything is resting against this, then obviously there will be a force acting on that particular body. So in this case, the block is resting against this face of the card, okay? So if this is the card here, so this is a block and this is just resting against this, right? There's no attached at all, there is no glue, nothing, right? Just resting against them. So now you might wonder that if it is resting, then why is it not falling, right? Because obviously it should fall, right? So now let's understand the dynamics here. What are the forces acting here? We need to understand this. So as I said here, if this is a cart here, if this is moving, so there is a force which will act on the body, whatever is here, right? What will that force be? That force will be equal to, on this, it will be mass into the acceleration, okay? Mass into acceleration. It will be the force acting on this. So now this is the force acting on this, which is the mass into acceleration, okay? Now let's draw it separately here to make it more clear to you, okay? Yeah, so this is a block here. The block tries to fall down with a weight, because it has its own weight. It will be resisted by a frictional force, it's F, okay? Now in this case, since it will be exerted by a force here, right? And what is this is equal to N, the normal reaction. What is normally, this is a nothing but the, as we said, this is the force acting by the card on the block is MA, okay? Now then, what is the frictional force here? The frictional force is equal to, as we said earlier, mu, yeah. So what is the frictional force here? The frictional force is nothing but equal to mu into N, okay? N is equal to MA, right? So this is equal to mu to MA, okay? So now coming back to this, right? Now if the body has to remain there, then the frictional force has to be more than the weight, right? Otherwise what will happen is that the body will ideally, it will fall down, right? Body will fall down. So the frictional force has to be at least equal or more than the weight. So that's why I'm saying force has to be equal to, at least equal to or more than the weight of the body. Means force is equal to mu MA, right? So it means mu MA, it has to be at least equal to the weight of the body, mu mg. So since both are positive, you can cut like this, okay? Means acceleration has to be equal to at least it has to be equal to, if not more, G by mu. Okay, so this will be the answer. Okay, so I hope you're able to follow this, right? Now I'll take you to one of the problems again, which is not in the same sequence, but I'll take you to this problem because this closely resembles the earlier problem, right? Closely resembles earlier, but the same concept is going to be applied here. In this case also, a block is resting against this the cylindrical drum here. Okay, so if you see from the top, now this particular cylinder is actually rotating around, evolving around this axis. Okay, now this block will also have its own weight, which will make it to fall. Okay, similarly here also there will be a friction. Okay, but the difference is that because of the rotational motion, now in that case, in the cart case, you saw that the cart is being pushed in the forward direction. In the cart case, what you saw is that it is being pushed in the forward direction. And what was the force here? MA. Okay, in this case, there is a revolving, or there is circular motion. The circular motion is happening like this, right? Correct. So if you look at from the top, if I'm looking from the top of this, right? If I'm looking from the top of this, so this is the block which you can look from the top. If you look at this circular motion kind of a thing, right? So there will be a centripetal force which will be acting inward. If I say that this is I, now if the block has to remain like this, now there's on here there'll be a centrifugal force. Okay, which I'm saying it is O. Okay, just to clarity. So I am saying this is a centripetal force. We call it centripetal force. Okay, and O, I call it the centrifugal force. Centrifugal force. Now, what will be the value of the centripetal force? Now, since this is an equilibrium, it is not going outside the circle. The block is not going outside the circle. It means in equilibrium. It means I is equal to O. It means this and this are the same. Okay, this and this are the same. I and O are the same. So now, what is the centripetal force? Centripetal force by definition is equal to mv square by r. This is equal to m r omega square. So this is our definition. Okay, this is centripetal force. So now this is centripetal force here. So this, if you look at this block, this centripetal force. Okay, so the centrifugal force will act like this, right? And this is the normal reaction, right? This is normal reaction here, correct? The normal reaction, and the normal reaction N will be the same as this. Okay, so this is equal to N. Now, what will be the friction force then? Because there is a friction force acting on this, right? As we say that this is the N. Okay, the friction force acting on this, friction force we know F is equal to mu N. We know that, right? We know that F is equal to mu N. So it means F is equal to mu N, and this has to be equal to mg. Okay, so that this does not fall. So the more the angular velocity, means the more the rotational velocity is happening, means what will happen is that the centripetal force will be the more, centripetal force will be more. It will also have an impact on the N. The more the N, the more will be the more the N, the more will be F. The more the friction force, the more the friction force, it will exert a resistance towards the top, and it will hold the body. The body is already resting against this particular cylindrical drum. It will hold the body against the drum. It will not allow this to fall. Okay, so mu N is equal to mg. Okay, it means, and we said that this is a mu into mr omega square. Okay, mu into n is r mr omega square, mu into m r omega square. Okay, mu r omega square. So this gets cut. Okay, means omega square is equal to G by R into G by R into mu. Okay. Now it's given that G is equal to 10, R is 1, and mu is given to be 0.2. So this is equal to is zero point 0.2. Then I can remove this one decimal here, add one zero here, so 50 is equal to 50. Okay. That means omega square is equal to 50. Means omega is equal to 5 root 2. Okay. So the kind of answer which is given to me, so this is the answer. Okay, friends, if you have any kind of doubt, please let us know. We will come back to you. Please add in the comment section. We'll try to resolve your doubts here. Okay, let's move on to the next problem now. Okay, in this one, it is given that a car is moving along a road at 90 km/h. It is moving along a road. So imagine that this is the car. Imagine that this is a car. It is moving. So imagine this is a car. Now car is moving this side, right? It is moving at 90 km/h. Okay. Now, since it is kilometer, first thing is that since it's kilometers per hour and the answer is given in meter, we have to convert the km/h to meters per second. Okay. So now you might be knowing that if I have to convert from km/h to meters per second, I need to multiply by 5 by 18. So 90 km/h is equal to 90 into 5 by 18. This is equal to 25 meters per second. Okay, 25 meters per second. Okay, so now, so 25 meters per second here. Okay, so this is equal to the, I can say that this is the velocity of the car. Sorry, this is the velocity of the car. I can write this is VC. Okay, the coefficient of friction. So now when the car is moving, in the forward direction, when the car is moving like this, so obviously there is a friction acting against the car in this direction, right? We all know that there will be a friction acting against this. And what is this deceleration which is caused, which is F by M. Okay, now what is the weight of this? Weight is equal to F is equal to mu M G, right? We know that the force is equal to mu mg. So this is equal to the acceleration or the deceleration here. I'm still writing deceleration means the negative acceleration because it is moving this direction. So there is a frictional force acting against this, which will try to reduce the acceleration for this body. F by m is equal to mu g. Okay. Now mu is given to me. The coefficient of friction as per the problem, it is 0.5, right? It's 0.5, so 0.5 into G is equal to 10. So this is equal to acceleration 5 meters per second square. So this is the deceleration of the body when it is moving there. Okay. Now we need to find out what is the least distance in which the car can be stopped. So now coming for the basic formula, which we know that v square is equal to u square plus 2s. In this case, I just need to find the distance. A we already know, u we know that the final we also know the v, it has to stop, right? So the final velocity will have to be 0. This initial velocity means what is the current velocity of the car, which is given to be 25, right? So it means this is equal to 0. This is equal to 25 square plus 2 into A is given to be 5 to S. Okay, so S is equal to 25 by 10. This is negative. Why negative? Because there is an acceleration which is there is actually negative, because of which this is negative here. Okay, so 25 square, which is 625. It's 1 second. We just so S is equal to 25 whole square divided by 2 into 5, which is equal to 625 divided by 10. Now you will see that I moved S from one side of the equation to the other. It should be negative. Yes, it will be negative because it is stopping now. This acceleration is actually negative here. Sorry, the acceleration is actually here. This is the acceleration. This is negative here, right? So if you put negative here, automatically it will manage. So this is equal to 62.5 meters. So the distance at which it will stop 62.5 meters. Okay, so given the answers, so 62.5 meter is the answer. Okay, now let's go to the next problem. A conveyor belt, there's a conveyor belt given to us. Okay, so the conveyor belt here is given that it is moving like this, right? It's moving like this. Okay, correct. It is moving in the forward, in the right direction. Okay, it moves at a constant speed of 4 meters per second. So speed, I can write that V of the conveyor belt is 4 meters per second. Now a block is gently dropped, right? So block is gently dropped on this thing, right? Now the coefficient of friction, so there is friction acting on this, right? So mu is equal to 0.5. Okay, what is the distance that the box will move relative to the belt before coming to rest? Okay, now let's see what will happen in this, right? So imagine this conveyor belt is moving like this. If the block falls, on this, now it has its own velocity, right? It has a minimal velocity, but it has some kind of velocity. Some kind, I'll write a VB, some kind of velocity it has with moving. Now because of which, because of inertia, obviously it will try to go this side, right? It will go this side, and the belt is moving on the right side. So because inertia, the block will try to move this side, the belt is moving this side. Now what will happen is there will be friction by the belt on the block, which will act in this direction. Okay, so I can write that friction by the conveyor belt on the block. I'm writing CB. Okay. Similarly, there is so this will also exert, the block will also exert some friction on this, or reaction on this, and I can say that this is the direction F by the block on the conveyor belt in this direction. Okay. So nevertheless, what will happen is that because of this friction, eventually the block will stop here. Okay, so the initial velocity which is there, it will actually come to zero. It will actually come to zero. The relative velocity will come to zero. It means after some times the block will actually come to rest on the belt. Okay, so when this is there, what will happen eventually is that initially the block is there. Okay, it will initially try to move this way because of reaction, right? Because of reaction, eventually after some time the block will say, okay, enough, now I have to keep quiet. Okay, so it means it will not go left or right, it will just remain like this, and its own individual velocity of the block will become zero. Okay, and it will just follow with the belt velocity, which is given to be 4 meters per second. Okay, got it, right? So this is very critical to understand the dynamics here, right? When the block is made to fall, so there will be friction acting on this block from the conveyor belt, and the block will actually exert some frictional force on the belt also. I think this is very important here to understand the dynamics, how this is working. Now going back to this again, so the acceleration again, what will be the acceleration of this? This is equal to mu mg, which is the frictional force, divided by m, is equal to mu g. Okay, So what happens here is that initially whatever the block, whatever the force, whatever the acceleration was there, actually this acceleration is acting on this, and this acceleration will actually make it to come to a velocity of the block as 0. Okay, so now A is equal to mu g. Okay, so A is equal to mu is equal to 0.5 into 10 is this thing, the g, which is equal to 5 meters per second square. Okay, meter per second square. So we need to know in what distance will it come to rest. Okay, so we'll again use same formula here, v square is equal to u square plus 2as. Okay, the final velocity is 0, it becomes 0. U is the initial velocity it will acquire, which is the velocity of the belt, which is 4. Okay, so 4 square plus 2 into A, acceleration is given to be 5. Okay, 2 into 5 into S is equal to 0. Okay, correct. Again, we'll see that. So 10s, 5 into 10s is equal to minus 16. Now why minus here? Because the acceleration which is here, right, this acceleration is actually negative, right? So negative gets cancelled out, so it means s is equal to minus 16 by 10 is equal to 1.6 meters. So it means after 1.6 meters the block will actually not have any of its own velocity, any of its own speed. The velocity of the block will become 0. So the answer is 1.6. Okay, so friends, we are in this, as I told earlier, in this particular exercise I have been solving. I have solved from 6 to 10 here. Okay, so friends, we hope you like the solution to the problems. If you do not like them, please add your review comments so that we will try to improve upon them. If you're liking them and if it is helping you in any way, we'll request you to like the video and subscribe to the channel. This will motivate us to create more educational content for you. Okay, we hope you to see you back in this channel soon. Thank you, friends. Bye.